So now in this video we have to find the derivative of ex 1 plus natural log of x. Now before solving it, I wanted to tell you something which is very important, and that is the derivative of log x, and the natural log of x is actually equal to 1 divided by x. Okay, now let's move on to the question. And in the question we have a function which is saying that Euler x 1 plus natural log of x. So let's just apply the differentials on both sides of the equation. Fx is equal to d by dx, ex 1 plus log of x. Now I want you to concentrate on this question for a while. This would be f slash x, which means that the first derivative of the function. Now this thing right over here is my first function, and this thing right over here is my second function. So this function, this derivative, this equation, it's actually consisting of two functions. Okay, and those two functions are being multiplied. Now how can we figure out in any term if there are two functions? Well, it is very simple actually. When you have x multiplied y, those are two functions, because x is defined by something else. X is another variable, y is another variable. So if you're having two different variables, those are two different functions. Same is the case over here. Euler x is a function in itself, and 1 plus log of x, wherever you're having a log, the natural log or a simple log, it is another function. So Euler is another identity, log of x is another identity. So if you are having those two things in one function, it means that that function is consisting of two functions, and the first function in that function is Euler x, and the second function in that function is natural log of x. Okay, so in this question we are having two functions which are Euler x and 1 plus natural log of x. Okay, so let's just follow the rules of multiplication while we are finding the derivatives. So the first function as it is, derivative of the second function, plus the second function as it is, derivative of the first function. Okay, so let's just continue. Euler x, now these are being added, so we can separate the derivatives. D by dx 1 plus d by dx natural log of x, we will use a bracket, plus 1 plus natural log of x. Now the derivative of Euler x, we studied in the previous video that the derivative of Euler x is actually equal to Euler x. Those are two same things. Euler x, the derivative of any constant is 0, plus the derivative of log of x, the natural log of x I told you is 1 divided by x, plus 1 plus natural log of x, Euler x. Okay, so over here we can multiply this Euler x in these terms. So we have Euler x divided by x. Okay, so Euler x was multiplied by 1, so it gives us Euler x, and in the denominator we have x, plus over here we can multiply these. So we have Euler x multiplied by 1 gives us Euler x, plus Euler x multiplied by natural log of x gives us Euler x natural log of x. We can take out Euler x common from all of these terms, so we are left with 1 divided by x plus 1, because Euler x taken out by common is obviously 1, plus Euler x taken out from natural log of x, we are left with natural log of x. Okay, at the end we can simply use this thing as LCM because it is in the denominator, plus x plus everything in the equation will be multiplied by this x which we have taken out as the LCM. So x natural log of x. So Euler x 1 plus x plus natural log of x divided by x is the derivative of Euler x multiplied by 1 plus natural log of x.